Yes.
If everyone wants to take their seats, there's a tea and cookies in the back. Feel free anytime to go get them. I'm Jill Sampson. I'm the chair for this event, and I am super excited about this because I met Dan actually in the dark at one of his nights, and they're pretty amazing if you've never been to them. So let me just tell you a little bit about Dan. He's the founder of the Marin Stargazers. It's a volunteer group dedicated to sharing the wonders of the universe with the public. As an amateur astronomer, he's presented dozens of events throughout Marin County and beyond to inspire people to connect with the cosmos. He grew up in Mill Valley in a musical family, and for over 30 years was a violinist with the San Francisco Symphony. So this is his second gig. He's vice president of the San Francisco Amateur Astronomers, and he helped the Mill Valley Library start its library telescope program, which Maggie's going to tell you about later. You can actually check a telescope out of the library. So he helped start that program. He's traveled several times to Australia to view the southern skies. He's an advocate for DarkSky International. He lives with his wife, Suzanne Leon, who maybe is here, she can be here, who's also a violinist with the San Francisco Symphony in Mill Valley. So just a couple quick things. Is there anyone who's never been here before? Welcome. These are public events. They're open to everyone. We're always happy when people come, and if you check the website, there's lectures going on all the time here. If you turn your cell phone off, that would be great. And after Dan's presentation, we're going to have a question and answer period, and then we're going to go outside and look through the telescopes. So we're looking forward to that. So welcome, and again, help yourself to tea and cookies.
Thank you very much, Jill, and welcome to all of you. I am Dan Smiley, founder of the Marin Stargazers. It's my honor to be with you here today and talk a little bit about astronomy with you and to experience astronomy. After the talk, as Jill said, we're going to go out right past these doors, and I have a couple of telescopes where we can safely look at the sun. So Marin Stargazers is an all-volunteer group that I started about 4 years ago. And our mission is to help people connect with the cosmos, as we say. We provide an opportunity for people to look through telescopes and learn about the wonders of the sky. We find that astronomy has a natural attraction to people of all ages, all backgrounds, and we set up telescopes in various public places, parks, community centers, schools, sometimes around Marin County. So connection is really at the heart of what we do, and in multiple senses. Of course, when you look through a telescope, you can connect to the object you're looking at. You can learn about it. You can understand some of the physics or the science behind it. Of course, when we gather, as we're gathered here today, we connect with each other as human beings, just as humans since the dawn of history, I'm sure, looked up at the sky and wondered what was up there. And in that sense, too, I think we connect to our human heritage. We can connect to the mythology and the folklore, the traditions that have been handed down, the constellation and the stories and myths of what the stars and planets were all about. Now the cosmos, what's that? Well, that's the universe, and it comes from an ancient Greek word meaning to order or array. So this was in contrast to the idea of chaos. So the Greeks found the universe something that was ordered. It was organized in a certain way. Perhaps it could be understood or explored. I was fascinated to learn of another meaning from this root word, which is to adorn. To adorn. So this is how we get the word cosmetic from cosmos. So I take this to mean that not only did the ancient Greeks find the universe orderly, but they found it beautiful. And indeed, when we have our events connecting people with the night sky, people cannot help but be impressed with the beauty, the majesty of what we can see in the night sky.
Whoa.
This object is called the Crab Nebula. It's what is known as a supernova remnant. This is what happens when a red giant star reaches the end of its life, it contracts, it collapses, it rebounds on itself, and it explodes in a cataclysmic event. In contrast, this is an example of where stars are being born. This image has been called the cosmic cliffs, and it comes from the incredible new James Webb Space Telescope. And this image, until a few years ago, was not seen in such detail before. And what it represents is a vast cloud of dust and gas from which new stars are being born. So some of these areas in here right now are creating new stars. It's like a nursery, a birthplace of stars. Well, speaking of ancient peoples, I came across this quote from the ancient Roman poet Ovid, who wrote his Metamorphoses around 8 AD. This is the section of his work when he discusses the creation of the world and the creation of mankind. And he wrote, "While other creatures looked downwards at the earth, man was given an upturned aspect and was commanded to behold the sky and raise his face to the stars." So, when we raise our face to the stars, what do we see exactly? What's up there? Well, at our events, when we set up telescopes, probably the number one object that we look at is the moon. So we're all familiar with the moon. The moon is our closest celestial neighbor. It is our satellite. We're familiar seeing the phases of the moon from crescent to a half moon. By the way, not only will we see the sun in a few minutes, but we can see the moon. It's out right now in a half moon phase. And a full moon, of course. But through even a small telescope, the moon comes alive and it presents an amazing amount of detail. You can see the craters and the lunar mountains. You can see these gray areas here. These are ancient lava flows. Although the early astronomers weren't quite sure what they were, they thought maybe those are bodies of water, so they called them the seas. And they named them after bodies of water, the oceans, bays, and seas. And here we have the Sea of Tranquility, where the first man on the moon landed. I want to point your attention out to this area in between the light and dark. This is where sunrise is happening on the moon, and it's an especially rich and interesting area to train a telescope because the low angle of the sunlight provides maximum detail and contrast on some of these features. Now, this line is called the terminator, and it has nothing to do with Arnold Schwarzenegger, as far as I know, but rather, as I say, it's where sunrise is happening on the moon. And I was fascinated to learn very recently from an artist friend of mine that that same word is applied in art. So here's an example of someone painting a round object, and this boundary area between light and dark in art is called the terminator. Now, I don't know whether that word first came from art and then was used in astronomy or the other way around, but I thought it was fascinating. And I want to point one thing out to you here, which is look at the shape of the light here. Do you notice this curve? This curve and the way the light plays on a round sphere is exactly how we see the phases of the moon. So in a moon phase similar to this painting, we would call that a gibbous moon, meaning it's somewhere between a half moon and a full moon. And in fact, this is a clue that the moon is a sphere. It's like a ball. So we can see it's round, but is it round like a plate? Is it round like a pizza? No, it's round like a ball. This is the only shape, a sphere or a ball, that will create light patterns in this way. Here's an example of what I talk about when I talk about the contrast we see at the terminator. These are what are called, the Apennine Mountains, named after the mountain chain in Italy. These are about 18,000 feet tall, and you can see the shadows they cast in a telescope. It's just a stunning view. What's especially exciting about observing the moon is that in a period of a few minutes, an hour or less, we can see movement. We can see those shadows moving. So right here, for example, these craters, the raised rims of the craters are catching the sunlight, but the floor of the craters lower are still in shadow. They're still in night. Perhaps you've seen a similar effect if you've ever seen a sunrise on a mountain range, the Sierras perhaps, where just the peaks of the mountains, just the tops and the tips are catching the light. But as the sun rises, they start to fill in. Well, as we go further out in the solar system, of course, we come to the planets. And perhaps our second most popular object, or maybe even our first, is the planet Saturn. Yes, even through a small telescope, you can see the rings. They're magnificent, and they are definitely real. In the small telescope, we can also see detail on the planet Jupiter. Jupiter is the largest planet. Both Jupiter and Saturn are examples of gas giants, because unlike the Earth, which is essentially rocky, these planets are made of gas. And these stripe or bands that we see on Jupiter are features in the atmosphere, the gas atmosphere of Jupiter. Going further out past the solar system, we come to stars. We raise our face to the stars. Well, here's a beautiful cluster of stars. I wonder if any of you recognize this line. Some of you do. These are the Pleiades, or seven sisters. This is what we call an open cluster. These stars were all born, at the same time, out of the same cloud of dust and gas, just as we saw earlier. The cosmic cliffs provide a similar example. So these stars are relatively young as stars go, maybe around 300 million years ago, years old, we think, which is relatively young. As stars go, our own star, the sun, is about 4.5 billion years old. So in a sense, this is a family of stars that was born together. They're traveling through space. And going further out into the galaxy, about 1,500 light years, we come to one of these nebulas from which stars are being born. This is the Orion Nebula. It's actually visible currently in the sky. And this is a photo taken at one of our star parties, actually. I have a special device which kind of heightens the effect. But this is a place, again, of where stars are being created. And finally, when we reach the limits of our own galaxy and we look into the vastness of the universe and interstellar space, we come across other galaxies. This is the Andromeda galaxy. It's about 2 million years, a little light years away from us. It's the dominant galaxy, what we call the local group, which is a group of galaxies, including our Milky Way. Well, let's put it all in perspective, shall we, with a slide from NASA with the modest title of The History of the Universe. Okay, well, we cover it all here, people. On the left, we start with the Big Bang, and on the right is the present day. At the Big Bang, we had the first atoms moving from left to right, the first stars, the first galaxies were created, until here, about 13.8 billion years after the Big Bang, we're sitting in this beautiful building here, trying to make sense of what it all means. But I want to point out one thing. It's rather difficult to see. There's this little tail or spot. It's actually before the Big Bang. Well, what could that be? Well, it turns out that many of the leading cosmologists think that something happened before the Big Bang itself. Something that actually created the entire universe, created the conditions for the Big Bang. Well, what could this mysterious force be that created everything and whose effects we still see today? Well, let's zoom in. I was expecting a laugh. Okay. Inflation was with us from the beginning, and inflation is still with us. Okay. Okay. I guess I didn't get the laugh. I had to work for it. This is actually cosmic inflation. It has nothing to do, as far as I know, with the price of eggs. But this is a scientific theory that says, in the very beginning, everything suddenly exploded and inflated at an incredible rate, faster even than the speed of light, in a fraction of a second, 10 to the minus 32 seconds. And as a result of this inflation, the Big Bang, the conditions for the Big Bang were created. This theory explains certain phenomena that we see today, including what astronomers call the flatness of the universe, and what they refer to as super horizon events. And this is the part of the presentation where I go back to something Jill said, which is that I'm actually a humble amateur astronomer. I have no professional training or background. I have no degree in science. I'm self-taught. I'm actually a musician by profession and career. So when the questions get too difficult, what I like to do is defer them and refer them to some of my fellow volunteer colleagues, some of them who do have advanced degrees in science and mathematics or whatever. They work at NASA or Stanford or what have you. So, but that's okay. I think it's good to keep humble, but I just wanted to kind of set the parameters there. Here we are in the beautiful Mill Valley Outdoor Art Club, and when Jill asked me to do a presentation here, I realized that I had a long time relationship with this building. As I mentioned, I was a violinist. I grew up in Mill Valley. My sister Mariko and I were born into a musical family. Our father was a violist with the San Francisco Symphony, and our mother was a pianist and a piano teacher. So we grew up in Mill Valley. We went through the wonderful public school music program at the time. I have to point out Mr. Joseph Angiulo, who is here with us today. I want many of you all know Joe, so he was an absolute rock star and superstar of the time. We had music classes and orchestra with Joe going back to elementary school, and also in Edmund McGuire Junior High School, as it was called at the time. So, and Joe actually has a connection to this building too. He reminded me he accepted his well-deserved Millie Award on this stage. And my wife and I played for that event. So so Mari, my sister, and I played the violin, and we played a concert on this very stage where I stand right now. I was in high school and a member of the Marin Youth Orchestra. That was back in 1971. Okay, you can date me if you do the math. But what I realized was that, of course, as Einstein said, time is the fourth dimension. So I stand here in the normal three dimensions that we all experience. But when Jill asked me to speak here, I was like, well, this is a wonderful experience to learn more about relativity. So I'm going to live it here before you. So I thought I would just briefly show you a few scenes from that time back in high school. These are actual archival images. And it was a long time ago. But as you can see, perhaps as long as the flood of Noah, I'm not quite sure what was going on here, but we made the best of it as we could do. Nevertheless, to me, they seem like more innocent and carefree days, and if a young violinist wanted to play the violin on the front lawn of Tamalpais High School, well, he could, and in fact, I did. That is me right there. So, yeah, that's me right there. But one thing I do want to point out is the clock tower here. Now again, Einstein, in his theory of relativity, said that time is relative depending on the frame of reference of the observer. Now, and we have clear and convincing proof of this back in the day. We lived relativity every day. So as you can see, depending on your frame of reference, the time was different. So this may have sparked my interest in science. I'm not quite sure. Well, speaking of time and relativity, we can fast forward several decades. Both my sister Mariko and I ended up going to Juilliard in New York, but we also both ended up coming back to the Bay Area. We also both ended up playing in the San Francisco Symphony. So this is me in the San Francisco Symphony. And I have a feeling I was still pondering the theory of relativity here, but just during the Mahler Symphony, probably. But the great joy that I had, among many joys in my career with the symphony, was working with my family. There were 5 of us, all violinists, who had the pleasure and honor of working together. So in the front, this is my wife, Suzanne, who's here. And next to Suzanne is her sister, Kelly. That's me. And then next to me, this is Mari. This is my sister, Mariko. And next to her is her husband, Sara. So as you can see, we had a whole cadre of 5 violinists that worked together. Wow. Now, I retired about 6 years ago, and I suppose you could say I traded my violin in for this telescope. And about 4 years ago started what became the Marin Stargazers. So what is our group like? What's it all about? What are the events like? Well, as I mentioned, we have a number of volunteers, about a dozen or so. Here is our volunteer, Philip. He set up his telescope in San Anselmo at Millennium Park. At this event, we partnered with the San Anselmo Public Library. And we helped them acquire a telescope, a library telescope. So this telescope can be checked out just like a book. This event was at the Mount Burdell Open Space Preserve in partnership with the Marin County Parks and Open Space District. The rangers there have been wonderful partners with us. It's a lovely spot. This is our volunteer, Richard, who teaches astronomy and physics at College of Marin. Sometimes we might set up just down the street at the Depot Plaza. We might have a solar star party, just like we're going to do in a few minutes right here. This is Muir Beach Overlook. Do you all know that? It's just a gorgeous spot. It has a stunning view to the west. You'll get some of the best sunsets ever there, if it's not foggy. This is Piper Park in Larkspur. We had an event there just a few weeks ago.
Yeah, I was there.
You were there? Okay, how was it?
Fantastic.
Yay! Glad to hear that.
Absolutely fantastic.
So we do events in a number of locations all throughout Marin, but one of our most popular locations is at Hockey Park, right here in Mill Valley. Do you all know where Hockey Park is? On Hamilton Drive, right by the public safety building, by the fire station and the police station. And here we partner with the Mill Valley Public Library, which has been a fantastic partner for us. And I want to mention, I'm very excited to mention, that if you're curious about our events, well, we have one coming up this Saturday. That's in 2 days. You are all invited to come. It's going to be from about 6:15 to 8 p.m. at Hockey Park. We're going to have a number of telescopes set up for your viewing enjoyment. Some of the objects we'll be able to see are the moon. The forecast is good right now, so we always want to take advantage of clear skies. Venus, Jupiter, and Mars will be prominent planets, and I think we're going to have a good chance of seeing Mercury. There's a nice low horizon to the west. Mercury is making an appearance right now. So we'll have our volunteer Rex here on Saturday, and I think he's bringing his homemade telescope here. He built this telescope himself, including the mirror, which he ground. As I say, we get people of all ages, all backgrounds who have this natural curiosity about the sky. People want to know more, and they want to look through a telescope, but they don't always know how. So this is why we have Marin Stargazers. All ages are involved. And here is our rock star librarian. This is Maggie Grabmeyer, and this is the library telescope that we helped the Mill Valley Public Library acquire. Here is the telescope in question, and here's Maggie herself. Maggie, if you don't mind. So Maggie has been just a fantastic and critical partner to organizing and setting up these events. We're very grateful to Maggie. Thank you so much for your partnership. One thing I'll mention, it is important to dress warmly for our events, so I encourage you to do that. At night, we usually follow up with what we call a sky tour or star tour, where we point out various objects in the sky, give you an orientation, and let you know more about them. And you can always find out more about when our latest events are by joining our email list, marinstargazers@gmail.com. Okay, well, I wanted to briefly review what was a banner year last year in terms of astronomy. Eclipses, auroras, and comets. Oh my. Yeah, we had all kinds of fantastic events happening last year. We had a comet with this long name over here, but I'm just going to call it Comet A3. And here it is adorning the night sky off of Point Reyes. So Moshe Chan took this beautiful image off of Point Reyes Lighthouse. And here is the comet in question, floating above the sea, and here is our Milky Way galaxy. Talk about adornment. This is an image I took myself. I think the comet in Mill Valley was brightest on October 13th last year. I live in the Scott Valley neighborhood of Mill Valley, and just up the hill, I went up the hill, and the comet was very prominent that night. It looked pretty close to what this picture was. There was a nice, long, broad tail. The next night, we had an event at Muir Beach Overlook with that wonderful view to the west. And Elizabeth Jones Sproko made this beautiful time lapse. You can see the comet moving. Now, that's largely due to the rotation of the Earth. Now, Comet A3 was a pretty nice comet, but in my opinion, the last truly great comet that was visible in Mill Valley was Comet Hale-Bopp. Does anyone here remember Comet Hale-Bopp? A few of you do. So I took this photo in April of 1997. It shows the comet over Mount Tam here, and we can see the Pleiades as well. And this photo led to our beautiful logo. You can see Mount Tampere and a comet. This logo was designed by genius designer Madeline Sklar, who lives in Mill Valley, and she's married to Scott Sklar, who is one of our volunteers. So thank you, Madeline and Scott Sklar. Auroras. So in a slightly darker area than Mill Valley, about an hour and a half north of here at Lake Sonoma, we had on one night a very special aurora display. The aurora was visible. And reports are that to the naked eye, the color was something like this, and it appeared something like this. Maybe not quite as prominent pillars, but definitely very noticeable. Now, with the magic of photography, everything popped a lot more.
Oh.
And with the time lapse, a beautiful aurora was on display for us. Now, auroras are caused by activity from the sun. The sun has an 11-year cycle of activity. We are at or near the very peak of that activity. So last year we got this amazing aurora from the sun's activity. And speaking of the sun, in my opinion, the highlight of the year was a total solar eclipse. This was on April 8th of 2024. And a total solar eclipse is, in my opinion, the most spectacular sight in nature. Did anyone here get to see the total eclipse? Now, I'm talking about when the moon completely covers the sun and not the partial phases here. Okay, some of you did. That's fantastic. It's a breathtaking, emotional even. Some people find it unsettling, but in every sense, it's an absolutely magnificent event. And I encourage all of you to see at least one in your lifetime. This was the path of the eclipse that stretched from Mexico up through the middle of the country into Canada. As soon as the moon covers the sun, this magical pearly white light appears around the sun. This is the corona, which can only be seen during the eclipse. This eclipse featured an amazing prominence display. So prominences are caused by eruptions of plasma from the sun. They remain connected, and usually unless they detach, but you can see the forces of magnetism keep this plasma from detaching, but it makes an incredible loop into the naked eye during this last total solar eclipse. This was plainly visible as a brilliant, like pink-purple finger sticking out, from my perspective, at the bottom of the sun. And in terms of perspective, can you see this? This is the Earth as comparison for size. So these are enormous, enormous features. Well, and now I hope you're all saying, well, Dan, this sounds amazing. When's the next one? Where can I go to see it? The beauty of solar eclipses is that we know exactly when and where they're going to happen. What we don't know for sure is what the weather will be like and if the skies are going to be clear. Well, we know that the next one is happening August 12th, 2026. And we think the best chances for clear weather will be in Spain. You can see this area here, roughly between Madrid and Barcelona. However, there are a couple of issues with this particular eclipse. It's going to be rather short. By the time it gets to Spain, it's only, I believe it's less than 2 minutes, maybe even a minute and a half. In addition to that, the eclipse is going to be quite low in the west, so you need a really good horizon and hope that it's clear in the west to be able to see it. My thought is if you only have one eclipse, you want to concentrate in the near future, look at the following eclipse. This is going to be on August 2nd, 2027. It will be the longest eclipse for the next 87 years. It will last almost 6.5 minutes at its maximum. And this should be a fantastic event if you can find some way to get there. You can see the path extends from southern Spain. It goes over Gibraltar, North Africa, Morocco, Algeria, and Tunisia, the southern Mediterranean, and the path goes right through Egypt. It goes right over the Temple of Luxor. So that could be an incredible sight. But do be cognizant of the weather in August in Egypt. That's something to consider. Suzanne and I have made plans to see this eclipse. We have booked our first ever cruise. So we are planning to see the eclipse somewhere south of Sicily in the southern Mediterranean. The weather predictions are pretty good there, so we'll keep our fingers crossed. Anyway, you've got over 2 years to think and plan about this. If you've never seen a total solar eclipse, I highly recommend it. But speaking of events that are coming up a little bit sooner, I mentioned the star party we're having on Saturday. There's also a very special event a week from tonight. There's going to be a total lunar eclipse. Now, look at the timing for this, and you'll see why we didn't plan an event ourselves. It's quite late. The totality starts at 11:30 at night. But if you're a night owl, or if you'd like to set your alarm, you'll see, and given clear skies, of course, you'll see a beautiful sight in the southeast sky. And now, in a total lunar eclipse, it's Earth's shadow that covers the moon. And as we look at the moon, we see it bit by bit covered by Earth's shadow until finally, when it's fully covered, it turns this kind of incredible shade of red. So that you can do on your own. That's a week from tonight, around 11:30 is when totality starts and lasts for about an hour. For another upcoming event, this is a bit far afield, but some of us in Marin Stargazers, we have a group of 4, are making the long trip to Australia. I'm leaving for Australia myself in about a week or two for an incredible event, an annual star party called the Oz Sky Star Safari. I'm in here somewhere. This was a previous event that I did. This event attracts from people around the world, but mostly Americans who want to see the southern sky. Well, what's so great about the southern sky? Well, to start with, it's the whole half of the sky we can't see here. And they have some incredible objects to look at, including the Magellanic Clouds. These are what are known as dwarf satellite galaxies. From the dark sky, these are plainly obvious to the naked eye. There's simply nothing like that in the northern hemisphere. You've got to go to the southern hemisphere to see that. I think I'm back here somewhere observing that. Any number of spectacular objects, globular clusters, and of course the Southern Cross. Southern Cross, or the constellation of Crux, is set in a beautiful, rich Milky Way field. Here next to it is an area known as the coal sack. You'll see how dark it is, and you can understand why it's called the coal sack. This is not a hole in space. Actually, this is an area of dust and gas, as we were talking about before. It's so thick, though, that it's obscuring the stars behind it, so we can't see through them. This is a magnificent thing to see, also with the naked eye. Well, this is going to be my 4th time to Australia, but I want to mention and introduce someone to you who's been to Australia 9 times. I've seen 2 total solar eclipses, but my friend has seen 7 in all. And I'd like to introduce you to someone who also lives in Mill Valley, who knows far more about astronomy than I ever will, and that is Robert Douglas. And here he is with his wife, Fran. Now, Bob Douglas is a retired mathematics professor at San Francisco State University. He's one of the leading amateur astronomers in the Bay Area, if not in the country. I've had the pleasure of observing with him a number of times. I always learn a lot from him. And he has written a wonderful book that I would like to bring to your attention. This book is called The Not-So-Little Book of Astronomical Curiosities. Here it is, and you can find it in the Mill Valley Library as well. So this book is a collection of 59 topics that cover all kinds of things you never knew that you wanted to know about. For example, where's the tallest cliff in the solar system? And what would it be like to jump off of it? Where can you find a moon that has a vast area covered in table salt? And what do GPS and black holes have in common? Well, my personal favorite is, how can you measure the speed of light using a microwave and mini marshmallows? Yes, science can be educational and tasty at the same time. So I highly recommend this book, and I'm very pleased to recognize Bob and his wife Fran are here today. Bob, if you wouldn't mind just saying hi. Thank you for your contributions. Bob has been a mentor and a really leader in astronomy, so thank you, Bob. We're going to look at the sun in just a little bit. Of course, the sun is our nearest star. Marin Stargazers cannot leave out our own star, the sun. And of course, the sun is huge compared to the Earth. You could fit about 110 Earths across the diameter of the sun. Well, here are the planets. I don't know if you can see very well, but this little dot down here, well, that is the Earth. And as we look at the telescopes outside, I think I'm seeing some sunlight and shadows, so that's promising. Just early before we started, saw a beautiful collection of sunspots. So sunspots are magnetic areas of the sun. They're a little bit cooler than the rest of the surface, which is why they appear dark. I mentioned we were near the peak of solar activity in this 11-year cycle, so sunspots are quite active right now. I have another telescope. It's a special telescope that shows only a very particular wavelength of light. This is called the hydrogen alpha wavelength, or H-alpha wavelength of the spectrum. And in this particular kind of light, we can see details we can't see otherwise. So there are sunspots, but we see these prominences here, which we saw during the total eclipse. So we may get lucky and see some of these prominences, these white areas, plages. These little stringy things are called filaments. They're actually the same as the prominences. We're just seeing them from above. And here's an example of one of the prominences. This is an absolutely enormous one. Again, in comparison, the size of the Earth is here. Well, there's so many wonderful things to look at in the sky, but there's something that I feel incumbent upon me to mention at our events, which is that the view of our night sky and our view of the cosmos is being threatened by light pollution. So here on the left is an example of what the sky looks like far away from lights. We can see the Milky Way beautifully. As we get closer to the city, the sky gets washed off. I can tell you Mill Valley is currently somewhere around here, but as I was growing up in Mill Valley, we could see the Milky Way. It was a little bit more like we see in this area. And the amount of light pollution, the amount of stars we're losing every year is increasing at a much higher rate than population, for example. Well, why is that? It has to do with the way we're using light and the way that light is used or misused. So light that goes up is wasted light, essentially. It just contributes to sky glow. If we have properly designed fixtures that go down and are not too harsh and not too bright, we can start to solve this problem. So what happened about 10 or 15 years ago, there was a whole revolution in lighting technology with LED lighting. Now, LEDs are good in a couple of ways. They use less energy, that's good, and they can be cheaper to run in the long run, which is also good. But the problem, especially with the early generation LED lights, was that they were very harsh and kind of glaring. People, you may remember when the first street lights came out, most of the street lights now in Marin in California have been replaced. People complained of a zombie light or a prison light, and what we want to avoid are these kinds of lights above what's called 3,000 Kelvin. That describes the color temperature, the color hue of the light. In addition to losing the view of the stars, we know from medical peer-reviewed studies that artificial light at night is actually not good for us humans. Now remember, we've evolved, all life has evolved on Earth over billions and millions of years in a natural cycle of light and dark. It's only been the last 100 years or so that our circadian rhythm has been disrupted by light. So there have been studies that show links between a number of conditions and diseases. We also know that light pollution is really bad for wildlife and ecosystems. Again, they also need a natural cycle of light and dark. As one example, millions of birds are killed every year in collisions with buildings or they become disoriented by light. Well, what can we do? There's one very simple solution. For any lights you don't need, you can turn it off. So just be aware of when you do use light. Of course, we do need light at night sometimes, but we need to use it when we want and in the way that makes sense. So, for example, here's the kind of light I see all over town, everywhere. Now, this light, though, what is it doing? It's basically shining right in our eyes. This light needs to go down where it serves a purpose. And when you do that, what happens? Oh, there's a set of stairs there. I can see the stairs now. So you see the difference. Here, you're essentially blinded by the light. It's going into your eye instead of down where you want it, being useful. In addition, I mentioned the color temperature. The harsher lights are these higher values of Kelvin. The warmer, more natural hues between 2,000 and 3,000 Kelvin are what we should be looking for. And one final bit of good news is that there are organizations that are doing something about this. And we have a fantastic organization right here in Marin. It's called DarkSky West Marin. This is a grassroots organization. It's run by a grandmother, a retired nurse, and people who have become concerned in the last 10, 15 years about losing the beautiful night sky in West Marin. And it makes sense to put efforts into preserving what is still the darkest area of Marin. So this is an organization well worth supporting. This is what they're proposing, to have West Marin designated as what's known a dark sky community. And if they can get certified as that, which means basically spreading the word, making sure people use lighting effectively and efficiently, this would be a wonderful thing. They are having an event next month, actually, in April. It's called Dark Sky Week. All week they're going to have events in Point Reyes Station. I think they have a night for going owling. They are giving a star party. I'm not going to be able to be involved with that. But again, I highly recommend supporting this fantastic organization. Well, I'd like to wrap up by sort of connecting back to the beginning, how we connect to the cosmos. I mentioned a little bit about supernovas. This is an artist's rendition of a supernova, but what happens when a giant star nears the end of its lifetime, it expands, becoming a red giant, and collapses on itself, and under the right conditions becomes a supernova. When it spews out all the elements it has created up to that point and more into interstellar space. Now these are actual images, again, from the James Webb Space Telescope of supernova remnants. We can see the result of stars exploding. So what happens when they explode? Well, here's something that shows the cycle. These supernovas explode, they create new clouds of dust and gas, out of which new stars form, new solar systems, and new planets. Inside those supernovas, new elements are created. When we had the Big Bang, almost everything was hydrogen with a little bit of helium. But inside these supernova furnaces, other elements like carbon, which make up our flesh, or calcium in our bones, or iron in our blood, and the oxygen we breathe. All these elements were created and spewed into space by supernova, where they created new stars, including ours, new solar system, including ours, and new planets, including ours. What does this all mean? Well, it means we are made of star stuff. When we look up in the sky, and I believe people feel this at some level at our events, we're looking back at our origin. We're looking back where we came from. So I believe when we raise our face to the stars and we connect with the cosmos, we are connecting with ourselves. Thank you all for connecting here today. I hope you enjoyed the presentation.
Question and answer.
Question and answers, as long as they're pretty easy questions, otherwise I throw it over the bottom.
Here we go.
Thanks. Hi. Actually, I have two questions. You said that Saturn and Jupiter are both made of gases. And in our world here, gases don't, they react to gravity. But and gravity would come from the center. So I'm curious why you have stripes that are, in the pictures, it looks like they're horizontal stripes for those stars, as opposed to kind of interior rings, where they would be, the lighter gases would go to the outside, and the heavier ones would stay in the middle. It's just like, because gravity comes from the center of our Earth, and I'm assuming in those planets the same would be true. So.
Well, that's not necessarily an easy question, Robin, but I'll give you a That's a really interesting question. I'm going to have to learn more about that. But yes, you're right. There's plenty of gravity on Jupiter. It is made of gas mostly, but it's enormous. So there's a lot of mass nonetheless. Those features that we can see, those stripes, my understanding is we actually are looking a little bit into the interior of Jupiter. So we're not looking directly at the surface. I don't understand all the planetary dynamics. I do know that the atmosphere, Jupiter's atmosphere, Jupiter rotates. Even though Jupiter is, I think, about 11 times the diameter of Earth, it's much bigger, but it rotates in something like 11 hours. So it's spinning really fast. And that activity, I think, stirs up this action. So I can't answer your question entirely, but I know there certainly is gravity. And I believe that the colors of the stripes that we see on Jupiter have to do with their chemical makeup. I don't know, Bob, do you want to add anything to that?
Talk about Jupiter, the gas band, extremely dense, not like our atmosphere. So those bands that you see, they're going much faster than the jet stream here, and some of them are going in the opposite direction. And I think the Great Red Spot is caught between a band going this way and a band going the other way.
Mm-hmm.
But there is really no surface. As you just go deeper and deeper, the density of the gas would increase to an incredible extent.
Yeah. Well, I hope that's informative to some degree. Did you have another question?
I did. Okay. So, sorry. Another question, and that is, our Earth, I know it's not really a sphere. You know, it's kind of got a little bit of shape to it. I don't remember if the equator is bigger or smaller. Is it smaller, as I recall?
I think the equator is a little bigger.
Bigger, okay.
As the Earth
Yeah, it
spins
bulges
apart.
in the middle.
It bulges in the middle. Like,
Right. And then, but the moon does not bulge in the middle? Or, I mean, you just said it's a sphere. I'm just wondering if it's really a sphere.
I don't really know. Does the bulge, I'm assuming nothing's a perfect sphere. And of course the moon rotates on its axis.
Well,
Okay,
the Earth rotates in 24 hours,
Yeah.
the Moon in roughly 29 days.
right. So it's
It's the spinning of the Earth that's causing the bulge at the equator. Well, when you spin once in 29 days, that's not too much of a
It may be less
Plus, there's
than
no
a-
water there to create the,
well, there could be frozen water, we think, in some of the
well,
craters
there's no
there.
oceans.
No
Which
true
causes
oceans.
the bulge out a lot easier.
Right, and tidal activity. Right.
I thank you for this presentation, it's super interesting. About dark skies, last year the city of Mill Valley paid to put in uplights in the redwood trees as part of their holiday lights. Have you seen these? They're like floodlights that are literally pointed at the sky.
Mhm.
And I'm wondering what you suggest.
Mm. Well, I take it that you noticed it, maybe you didn't like it. Look, when it comes to holiday lighting, I find myself a little bit more lenient. I don't want to be the Grinch that stole Christmas. However, uplighting in general, I will say I've noticed it becoming, and the question is about uplighting in Mill Valley. Certainly, I've noticed an increase in uplighting, in particular in regards to landscape lighting, which has become very popular in my neighborhood, at least, and everywhere I go. And I understand the attraction, you can light up your garden, it's beautiful at night. But yes, lights that point up do light up the sky. They are not good for protecting the night sky. They're really not good for your garden either. My understanding is, trees, plants, and pollinators, they all need that same natural cycle of light and dark. So I haven't approached the city of Mill Valley on that particular thing, but I would say anytime you have a concern, you should express your concern.
Thanks. Lovely presentation, and I had two fairly simple questions, I think. One is, I noticed, at least from the photos, it looks like a number of your events are actually in the day. And so I wondered if that's the case. And so, I mean, obviously we're going to be looking through the telescopes now, and I guess I was surprised. I was assuming everything would be at night. And then my second question is your organization involved in any way with the astronomy nights up on Mount Town? So those are my two questions.
Right, so the first question was about, I'm sorry, I'm thinking about Mount Town now. The first question was about our events during the daytime. So in general, they are not. Most of 80 or 90% of our events are at night. It could be that some of the photos that you saw we're a bit overexposed so you could actually see something, because it's actually difficult to take photographs, of course, at night and to be able to see anything. So, but we do occasionally do solar events, as we're doing today. We have done a few from time to time. As far as the events on Mount Tam, so there are some current events, public star parties happening on Mount Tam. Those are under the auspices of another organization I'm involved with. My other hat is I'm the vice president of the San Francisco Amateur Astronomers. This is a long-standing club based in San Francisco. We have public events. We did 2 of them last year up at Rock Spring with Mount Tam State Park, and we are trying to organize more for this year. So I have a personal connection with those events. Marin Stargazers, many of the members and volunteers of Marin Stargazers also participate in those events.
I want to thank you for a wonderful presentation, Marin. And I was amazed under your staff at Lake to see the nebulae through the telescopes there. I couldn't believe that we could see it from the park. But I have a question about the James Webb apparently is trying to look into the oldest parts of the universe. And my question is 2. One is, can you aim your telescopes in the direction of what you think is the oldest parts of the universe? And how do we know that we're not in the oldest part of the universe right here?
So the question is about looking into the oldest part of the universe, and how do we know we're not in the oldest part of the universe? Well, I refer to Einstein, who says that everything is relative depending on your frame of reference. If we, to someone at a great distance away from us in the universe, to them we could seem like we were in an older part. So in terms of, at our star parties, trying to find the oldest part that we can look at, well, look, we don't have the capabilities of the James Webb Space Telescope. You can point in any direction and find a faint object. We know certain places where we can look as amateurs with the kind of equipment that we have, where we can find what we know are the most distant galaxies. Those would be the furthest away from us and the oldest light that come. So I hope that addresses your question, because we're getting a little bit, again, out of my field of expertise. I don't know how much you can tell, I'm a little bit faking it here.
I was wondering if you could speak a little bit more to that 11-year cycle of the sun's magnetic energy changing, and to the extent that I remember reading something about the magnetic poles of the Earth shifting, or was it the sun shift as it builds?
So the question is about the magnetic poles of both the sun and the Earth. Well, yes, I think the answer is yes over long periods of time. For the solar cycle, my understanding is over the 11-year cycle, the polarity of the north and south magnetic poles on the sun actually do reverse in that cycle. There's another point that I recently learned, which is that the northern half, the northern hemisphere of the sun, is not exactly correlated with the southern hemisphere. So they kind of lag each other. When scientists are trying to calculate when the exact peak of that 11-year solar cycle occurs, it may occur in 1 month in the northern hemisphere, and then the other hemisphere catches up. So, and I believe over the history of the Earth, I'm sorry if I keep throwing questions over to Bob, but I might have to. But in the long history of the Earth, I do believe that Earth's polarity, magnetic north and south, have changed over time. Isn't that right, Bob?
It has. By the way, to answer your question, you asked. You asked the question, how come we're not in the oldest part of the universe? Actually, everything in the universe is the same age. Look at it this way. Suppose you're going to make a bread pudding, and you have raisins in it, and it's very small, and over time, it's expanding. Space is expanding. And all the raisins are moving, they're expanding, and we're on one of the raisins. But all the raisins are the same age. There is no oldest part to the universe. We're all the same age. We're all raisins.
There you have it. Raisins, grain, marshmallows, Bob covers it all.
I have a question about looking at the night sky with your naked eye, with no, what is some of the best places to see the stars in Mill Valley, so you can see the whole space, and how long does it take for your eyes adjust to the maximum of looking at it with the naked eye?
So the question has to do with where in Mill Valley can we see the most amount of sky, I think, and the darkest sky, and also letting our eyes adjust to the dark. Well, Mill Valley does have light pollution, as we all know. It's better than some other parts of the Bay Area. In terms of being able to see the whole sky, when you come to a place like Hockey Park, certainly there's lights around, but we have a pretty good view of most of the sky, especially to the west. If you go up, let's say, around the Four Corners area, we have a little bit of a height there. There are certain knolls up there, so you get a pretty good view. But again, you're going to be looking at times over to San Francisco, the East Bay, there's quite a bit of light there. So I would say more than having a 360 view, what you want to do is try to get as far west, which is away from the light pollution, towards the ocean where there's less light pollution, and to block the light you get from San Francisco and the East Bay. Going outside of Mill Valley, going towards Point Reyes would be more ideal. You can go actually at Stafford Lake, which is in Novato, or if you go over the hill, towards Samuel P. Taylor Park and Nicasio, that area tends to be darker. In terms of letting the eye adapt, that's a very important thing to do. I'm glad you mentioned that. Our eyes are designed to adjust to the dark. In fact, our eyes produce a protein called rhodopsin. And over about 20 minutes, let's say, 20 to 30 minutes, the eye produces this protein, which actually enhances the receptivity of, it's either the rods or the cones, or maybe it's both of them, so that you actually can see in the dark. People are amazed how much they can see once they let their eyes adjust. So I recommend wherever you do go, give yourself a good 20 minutes. Don't use your iPhone, don't use any white light at all. And even from light pollution, you will start to see many more stars than you would.
I wanted to thank Dan for this incredible presentation. And I wanted to leave some time for everyone to go out and look at the telescopes. And I also want to thank Maggie for being here. And she'll explain to you about checking out the telescope from the library, which we're all going to be fighting over in a few minutes. That'll be outside. So please join us outside. You can continue to ask questions. Dan will be here for a while. And thank you so much for being here.